Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good day to all my beloved students. This time we will learn how to solve the problem related to the heat transfer, radiation, emissive intensity and solid angle. Let's say we are given this question. A small surface area A1 equal to 0.001 meter square is known to emit diffusely. The total intensity associated with emission in the normal direction is 7,000 watt per meter square steradian. So bear in your mind, if we mention the steradian, meaning that it has the direction, dedicated direction. Radiation emitted from the surface is intercepted by three other surfaces, which is A2, A3 and A4. This one, A2, A3 and A4, equal to the 0.001 meter square, which the length for each 0.5 meter referring to the A1, which is this one, and are oriented. So the question, what is the intensity associated with emission in each of three directions? Okay, so A2, A3 and A4. What is the solid angle subtended by the three surfaces when viewed from A1? Solid angle refer to the omega, omega 2 to 1, 3 to 1 and omega 4 to 1. And last question, what is the rate, meaning that the Q at which radiation emitted by A1 intersect by the three surfaces, meaning that Q2 1, Q3 to 1 and Q4 to 1. So this is the schematic, I would say schematic diagram to simplify all the information from the question. So this one is the A1, okay, A2, A3 and A4. So we remark all the length or R. So R2 0.5 should be same, R3 0.5 and R4 0.5. So the best part of this arrangement, the A3 is very straightforward, is opposite from A1. Okay, so just front of the A1, A3. A4 45 degree, which is A4 facing to the A1, and then the A2 have the angle 60 degree from the A1 from these references. Okay, so that is the information. So the things you need to know, we need to ensure all this area facing normal to the A1, which is A3 is directly to the A1, A4 also directly to the A1, but the A2, we need to do some sort of the adjustment to ensure that it can turn normal to the A1. So the question, what is the intensity associated with the emission in each of three directions? So from the definition, as we know, of diffuse emitter, the intensity of the emitted radiation is independent of the direction. So meaning that A2, A3 and A4 have same experience of the irradiance, which is the 7,000 watt per meter square steradian. Okay, so it comply for all the three cases. And then next question, what is the solid angle subtended by the three surfaces when viewed from A1? So from this question, we know that the A2, A3 and A4 have the differential surface area, which is, we can compute the equation for this A2, A3 and A4 like this one. Okay, so omega approximate delta En over the R square, which is N refer to the maybe A2 with the R at A2 refer to the A1, A3, A4 and etc. For this case, we go for the A2, A3 and A4. Bear in our mind that R all is the same, right? 0.5 for each A2, A3 and A4. So that might be more simplicity in terms of the solution. Okay, we try to remask this schematic again. Okay, so A3, A4 and A2. So by having this equation from the 3 to 1, 4 to 1, the solid angle same, because A3 and A4 same area. Okay, so and also the R also same length, so that from the solid angle for 3 to 1 and 4 to 1, we insert all the information and we get that omega 4.0 times 10 power negative 3 steradian. Okay, so because the area and the length is the same for the 3 and 4. But bear in your mind, this one is only applicable for the case of 3 to 1 and 4 to 1, because these two information is normal to the surface as A1. But for the case of the A2, we need to do some sort of the adjustment to ensure that it normals. Then after that, we are using this equation to get the final answer of the solid angle. What is the solid angle subtended by the three-phase surface when viewed from A1? Surface A2, as we know, not normal to the direction of the radiation, which is we need to perform this equation to obtain the normal version of the area, and theta 2, angle between the surface normal and the direction of the radiation. Okay, from here, okay, so originally A2 is straight here, and then we need to go for the A2 cos theta for this angle to get normal to the A1, and then we can put the value of solid angle like this: omega 2 to 1 A2, this A2 cos theta 2, which is the 30 degree, over the R square, which is this the value, and finally we get 3.46 times 10 power negative 3 steradian. Okay, so that's the solid angle for the omega from 2 to 1. Okay, this one. Okay, so this one. Next, what is the rate at which the radiation emitted by A1 intercepted by the three surfaces? So the rate at which radiation is intercepted by each three surface using equation. This is the general equation: Q1 to, let's say, 1, 2, 2, 3, and 4. In this case, it's 2, 3, 4. And I is the irradiance, 7,000 watt per square steradian. A1 is the value of the A1 area. Cos theta refer to each case, A2, A3, and A4. And then the solid angle for each case, referring to the condition 2, condition 3, and condition 4. So we start with the Q1 to 2. By referring this equation, 7,000 refer to the irradiance. Okay, so this 10 power negative 3 meter square refer to the A1. Cos 60 degree refer to the case of angle for the according to the schematic diagram. And then this one is the omega 346 times 10 power negative 3 steradian, and you should get 12.1 times 10 power negative 3 watt. The same goes to the Q13, which is same irradiance, same area, but the difference is the cos 0 degree, which refer to the opposite from the A1 to the A3, okay, which is 0 angle, and then the solid angle is 4. times 10 power negative 3 radian, and you should get 28 times 10 power negative 3 watt. And finally, Q1 over 4 with the same radius, same area, but different angle, which is 45 degree, times the same radian or solid angle from the case of Q13, which is 4 times 10 power negative 3 radian, and you should get 19.8 times 10 power negative 3 watt. Okay, so next, this is your part with the more or less same question, which is what is the rate at which radiation emitted by A1 intercepted by the three surfaces by taking 5000 watt meter square, and all R is 0.75 meter, which is this value blue in color, so change from the original question. From the original question is 7000, so change to 5000, and then from the original question is 0.5, so change R equal to 0.75. So try to get the Q12, Q13, and Q14. So also provide the final answer for you guys to refer with, just to check or cross-check for your own references. If the question is not tally with this information, so you may jot down in the comment so that you can cross-check. Maybe it's a wrong calculation or maybe typo or something. So we open for discussion. With that, thank you very much. Enjoy your exercise and all the best. Assalamualaikum warahmatullahi wabarakatuh. Thank you.